So question 10 from the practice exam, we've got our propionic acid and sodium propionate. I just basically wrote them as we have our weak acid we have 1 molar of our weak acid, we have 1 molar of our conjugate base. And then to this solution, I add 0.1 molar HCl, which is our strong acid. So a lot of students are getting hung up in the name and what is this and what is this and what does the sodium do of that. So I've just been kind of writing them as, HA, that's my weak acid, A minus is the conjugate base, because literally we don't need to get hung up on the name in the buffer. We just need to think about what are the concentrations that I have, what's reacting with what. So there's my 1 molar, there's my 1 molar HA, A minus. To that, I add my strong acid, my 0.1 molar HCl, which is a strong acid. So where does that strong acid react? What does that strong acid react with? Yeah, it's going to react with the conjugate base. So we're going to expect to see that concentration go down. And the product of that reaction, right? If I take the conjugate base and I add a proton onto it, the product of that is more HA. So that concentration goes up. By how much does it change, right? By 0.1, because that's the acid that reacts. So we're going to subtract 0.1 here. We add 0.1 here. So after the reaction, right, I'm going to have slightly more of my weak acid and slightly less of my weak base. So 1.1 molar HA and 0.9 molar A minus. Now I can do the Henderson-Hasselbalch equation because I have the concentration of my acid and its conjugate base. So pH equals the pKa plus the log of the concentration of my base over the concentration of my acid. So pH equals pKa is the negative log of Ka, 1.3, 10 to the minus 5, plus the log of my base. Well, my conjugate base is 0.9. My acid is 1.1. So pH of that solution equals negative log get like a 4.80 as the pH of this solution, this buffer.